Well, that is the 8 a.m. siren. Welcome in, everybody. Welcome in, Uki. Today, we've got a bit of a special stream. I've got this Royal Broadsword model that I want to cut up and show you how to process it for 3D printing live on stream. So, before we dive into this, how do we print this, right? This is currently, oh my god, what the heck? This is currently a Fusion 360 model. How do we get it into something that we can print? Well, one thing we can go is one thing we can do is right click on the top assembly here and go to export, choose um choose our file path here. Do 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 do. And we can save it as a step file because they're better. We can call that Royal Broadsword step. Easy peasy. Save it. There. Bada bing, bada boom. We'll open up Bamboo Studio. Wait for that to load. There we go. New project. We'll grab our sword to upload. Royal Guard sword, real stuff, Royal Broadsword. And we got the step file. We can just throw that right in there. Bada bing, bada boom. We can wait for that to load. Okay. Okay. It's coming. It's gonna load. It's gonna do it. It might be choking. I do have OBS and Fusion running right now. And spoiler alert, this is a joke. It's not gonna work. I mean, it is gonna work, but it's not gonna be anything that we can print. Yeah, see, oh wow. Okay. Now as you can see, this will not fit. Okay, and there are cutting tools built into Bamboo Studio in order to be able to slice things up, but that's really hard. Jesus Christ, it's taking forever. But yeah, this is taking forever. So, oh, yeah, we could slice this up, right? We could cut this in half. We could, okay, I don't even want to do that. It's going to choke on me. Oh my God, it is choking on me. Let's just kill that. Anyway, so here's what we're gonna do, right? We need to cut this up to be. Here's what we need to do. We need to cut this up into a form that we can actually 3D print it, right? And the first step before we even cut it up is we want to make sure it is something that will be 3D printable, right? And that means completely closed bodies entirely. Oh my God, this thing's still not dying. No, it's fine. And that means completely closed meshes, right? So if you go in here, go into your tree, and look at the bodies, you can see none of them are meshes, right? None of these are, well, they're all meshes, but none of these are open meshes. Like if I um, went in here and I went to mesh, or surface rather, and I erased a face, now you can see here it turns into this orange symbol, which means it's an open mesh. And if we Control Z undo that, it's a closed body, right? A closed mesh. Now everything needs to be that. Now another thing that we need, or another thing that we need to pay attention to, is we want to make sure that there is nothing overlapping, right? There's no interference between any of the models because we can't print two things that are inside each other. So what we can actually do is, apologize for everything being in Japanese, we can go to our inspection tab here, and you see these two squares overlapping where it says interference. I mean, it says hosho, but interference. And we can click on the top level here, and then we can hit calculate, and it will tell us between if any of the top level bodies have any interference. And it tells us, okay, right here, with 813 millimeters cubed, is this body. The sheath gilding and the do not use sheath cord. Now, spoiler alert, I'm going to hit OK. That's this body and that body, right? Spoiler alert, this body I don't like. We're not going to use it. It's not actually something that I want to print. It's just a guide. So you don't need, so I don't need to care about that. But theoretically, if you did care about that and you wanted to make it so that two things weren't interfering with each other, one thing you can go is in your solid tab, you can go into combine here. You use combine, and then you pick the body that you want to cut away from. So let's say I wanted to cut away from this body, and then you pick the body or bodies that you want to do the cutting. So I want this body to cut away from it. But instead of doing combine, we're going to do cut, kiritori. And then we're going to say keep tools. We're going to check that. So that what this does is it makes it so that the tool body doesn't go away. And then I'm going to hit OK. And then if we can press V to make this go invisible, you can see it cut it away, right? Control Z to bring that back. And then if we go into our interference, nope, that's the wrong one. If we go into our interference tool again, and we click over there, and we run the interference tool, it'll do its calculation. And then it says error. I think it said the geometry was inconsistent. But I think that just means because there is nothing. I don't know why it's throwing an error. It should just come up and say, oh my god. Fusion's 360's errors are crap. Anyway, there's nothing there, right? What we can do is, if we really want to check, we can click this one and click that one and click go. And it says we could not find any interferences. Okay, cool. That's awesome. But we want to we don't want to cut this out because, like I said before, this is not something that we want people printing. So we don't care if it's running into other bodies in here. So now that we have established that on this model there's no interference. Okay, now that we've established on this model there's no interference, no intersecting bodies, at least not ones that we care about. What the heck? There we go. I don't know why this came back. At least not the ones that we care about. We need to slice this up in such a way where we can actually print it. So, let's talk a little bit about this. When you're cutting it up into pieces, you have to think about quite a few things before you start making your plan of how you want to separate them up, right? The number one thing that you got to keep in mind is the realities of 3D printing and the physical world, right? 3D printing, number one, flat bottoms are really good for 3D printing. So when you're cutting it up, you want to have a lot of flat spaces that you can place down onto a print bed. Number two, you want to have as few overhangs as possible. When you're 3D printing, if you have any overhangs, you have to use support materials, and that wastes material. So you want to avoid that as much as possible. Number three, you got to make sure whatever you're doing, you don't cut any walls too thin. So if any slice you make creates something that is thinner than the nozzle, that is one, thinner than the nozzle height, the nozzle, that is one, thinner than the actual whole, how do I want to say this? One, that is actually thinner than your nozzle size, and two, not so thin that it will break immediately upon, any sort of handling, right? And number four, it needs to be physically assemblable. If you have two pieces that you want to put together and you want to put two rods in order to join them, those two rods need to be parallel. If they're not parallel, then you can't physically put them all together, right? Okay, so the second big thing you need to think about is the limitations of your device. Now, there are probably 3D printers out there where you could just kind of chuck this model onto it, and then you're good to go. Like there's probably giant, meter long, there's probably, I've definitely seen giant 3D printers out there that could handle printing this entire thing. But even with those printers, it would be extremely inefficient. You'd be wasting a lot of supports. You would have to be doing a lot of multicolor printing. It would be a huge pain in the butt. So you want to keep your own printer's limitations in mind to cut up something that is physically printable and feasibly printable on your printer. Number two for that, you got to think about the number of colors, right? I have 2 AMSs hooked up to my printer, so I can print in a maximum of 8 colors. So if I really wanted to, any of these parts could be a total of 8 colors, and it wouldn't matter to me. Well, I should amend my statement by saying, and I could theoretically print that. And then the last thing you need to think about is things like nozzle size or other limitations that your printer has. If your printer has only a 0.6 nozzle on it, which I don't know why you got that, maybe you don't want to cut this up in such a way where you would require a 0.2 nozzle for it, right? Let's see, what else? The last thing you need to keep in mind is your own personal preferences. You might want to upload your design to the internet like I do, so you might want to think about making it easier for other people to print. You might want to, you might have the capability of printing in 8 colors, but you might not want to because that wastes a lot of filament. Because you might have the ability to print in 8 colors, but you might not want to because that's a lot of wasted filament purging in between color swaps. And then you might want to do something like have no supports, right? So you don't waste any material. There's nothing wrong with using support materials inherently, but you might, you might not want to, okay? So once you've figured that out, and once you've figured that out, and once you've done the check for interference, and once you've done, and once you've made sure that all of your models are separate, now you need to make a plan of how you want to cut this up. Okay? So let's take a look at this. Now, I highly advise that you create your entire plan for how you want to cut this up before you do any cutting. Okay? So I've separated this out into 2 main models, the sheath and the sword, right? Boom, sword, sheath. So for sure, these are 2 separate models already. One thing we might want to check is we want to make sure that the sword can actually fit inside the sheath. Now we know these don't interfere, but will this thing be able to be inserted? And spoiler alert, I already did a check for this. Oh. Spoiler alert, I already did a check for this. You can see if I drag this intersection analysis here. By the way, you can do a new one of these by going up here and then going down to intersection analysis. Like if you go here and you look at it side on, you can see I cut this thing entirely. Oh, but wait. I may have cut it out, but I didn't give it any wiggle room. See, it's good to check these things. Right, like these things are like perfectly touching. So they won't be able to slide past each other. So what I'm going to do is I'm going to go into the sheath here. I'm going to turn the sword off. And that's on the main body, isn't it? No, it's on the entire sheath. Okay, so what we're going to do is we're going to go into our press pull, and I'm just going to select all these little guys here. Everything that will go along the part where that thing slides in. And in my experience, if we tell it to go off by minus 0.3 millimeters, that will make it so that it gives it enough wiggle room so that it will be more than fine. So there we go. So that's okay. So now we know this can fit in. We've done the analysis. We know that it's not going to bump, or we're pretty darn sure it's not going to bump against each other. Okay, right? We'll save that up. So, bit by bit, come on. So we know we don't care about this. This is not something that we want people to print, so whatever. So in the sheath, we've got 4 components here. The end decoration, the main body, which contains all of these purple and yellow stuff. The sheath gilding, which is this entire gold thing here. And then the sheath cord, which is something we don't care about, right? So here's my idea for the sheath gilding here. I want to print the whole main body together. I don't want to bother trying to print out these separate designs because I have an H2D. It has dual nozzles. I can print in 2 colors. And quite honestly, I think it would be a super huge pain to try to print these things separately and then fit them together like properly. I don't want to do that one bit. And another thing, so we'll print that together. We'll print that like that, okay? So we'll print this main body. So we'll print this main body all at once, but obviously it's super long. We can go up to our measure tool and we can measure from roughly here to there. And that's 720 millimeters, a little bit more because it's not measuring the entire length. Now I have an H2D which can print up to about, what, 300 millimeters tall, something like that, around there. However, I do want this to be printable by other people, so I will probably want to cap this at maybe like 250. So if I cut this into 3 sections, like this, boom, boom, then I can make it into pieces that can all fit onto my printer. So that's okay. Now, the question is, once I've got this thing built together, sliced together, how are we going to get this on it? See, remember, so we need to remember what I was talking about with it has to be physically assemblable, right? We cannot just print this out as one piece, even if we had a big enough printer, and then just insert it into here, right? That's what it seems like. But maybe if we cut these off, if we cut it off right here, we'll do another measure here. 194. So if we cut these guys off so that it's easier to print, make a cut right there, boop. Cut these two off. We can print this thing, and this thing can just slide right on like that. And these two guys can fit in the top. Can fit in the side, I guess. Yeah, that should work. There. And then this guy, how should we do this? I think we should do something similar. We'll cut it off right here, and that will give us a nice flat bottom to print this guy on. And then we can cut this guy in the side, and then we can just put them together sandwiched up top. Okay. And then for the sword. The blade here, again, we're going to need to cut into quite a few pieces. Let's see how long-ish this is. Roughly 800. So we might need to cut this into 4 pieces. So I'm thinking maybe we'll cut this off right here and make a nice strong, or maybe right here, so we're not cutting in between these. Maybe cut right here, so we're not cutting the any of these guys in half, any of these design things in half, and then we can make maybe a cut here, boop, and then maybe a cut here, boop. If we do a quick measure. All right, 291. Oh, okay, that's a little bit too long. So then we'll maybe just go 250 millimeters from here, and that'll be the end of that. Okay. And that will be the blade cut up. Ooh, for the design, I think what we can do is we can just extend it down to pierce in, and then we can just put them in, print them out separately, and then stick them in like that. Ooh, and for this part, see, because this is a separate body than the center. So I think what we can do here is what we might be able to do is make an interface here so that the outer blade here can hold the center pieces together, and I'll show you what I mean when we get to it. As for the cross guard here, ooh, this I think we can extend down and then just slot it in. But for this design, I don't think we need to. I think we can just not split it apart, and then we can just use a filament change to get this design printed on. I think we can just extend. Ooh. let's look at it from the right. This is the same color as that. So I think we can just extend this down into the let's measure this. And if I'll give you where did it go? There was a setting. Oh no, 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 no. If you choose 2 points, it can tell you the distance. So this is a little bit higher, but we'll cross that bridge. It'll be fine. It'll be fine. Okay, so I think what I was saying is we can just extend this guy down into the cross guard here so that it just fits directly in. And then I think if we I think we can cut this off here like that and then extend the handle just into the cross guard straight up, and that could work. Okay, so that's the plan. So the first, and we'll save this up. So now that I've figured that out, I'm going to go into all of the different ways that you can cut things up. Now, the first thing that I'm going to do, I think, is cut up the blade. And I'm going to show you a special little way I've learned to make things really strong. So I'm going to show you. So grab my prop here. All right. So let's talk about strength, right? Because if you're making a sword, you want to be able to hold it by the end and then not have it, break when just holding it out like this. You want to at the very least be able to hold it out at 90 degrees from the ground and not have it break under its own weight. Maybe it's not going to be the most swingy. Maybe you won't be able to swing it around, but that's fine. At the very least, you want to be able to hold it without it breaking, right? So here is a rod. Now, I printed this rod sitting down like this. And because of that, the printer printed the layers on top of each other like that. And because of that, it's really hard to break. Like, all of the layers are working against me trying to break it. Doesn't matter which way I try to bend it. It's strong like that. So when you print it like this, it's really hard to snap the side, and it's really hard to pull apart. Like, it would be really hard to do this as well. Because every single printed layer is one continuous outer loop, right, in this direction. But if I had printed it up like this, and the layers were stacked up on top of each other like that, it would be really easy to snap. It would be much easier to pull apart. It would be a much weaker part in that direction. But if you take something like a handle, right? You might be tempted, okay, print the handle like this. That way it won't break. And that would be a good idea. But if you have another part that you want to stick into this, in my experience at least, what you should do is print it like this, so that the layers are side to side like that, and then print the print a peg on its side. So that way you have a peg that's hard to bend like that, but it's being held by a layer that's surrounding it. So it's kind of like my hand holding it like this. Like the handle is printed layer by layer. Boop. So now it's being held onto like this, right? So if you put it in like that, that's pretty strong. But if you take a giant blade like this and you slot that on, it'll let me. You have this very long sword, right? This is 2 entire printer lengths out from the handle, but you can swing it around like this. And if you put a little bit of glue in there so that it doesn't pop off, then it's much, much, much sturdier. Now, here's an example of an actual sword that I have made. You know, you can see I can swing it around pretty darn loosely. Now, of course, if I swung it this way and then really fast swung it that way, it might break. But as it is, it's a pretty darn good, pretty darn light, and I'll talk about how to do that later, sword. Now, if you want to get really extreme about it, hold on. Just to test the proof of concept, hold on here, my mic cord is tangled. Okay. All right, can you still hear me? Testing, testing. Okay. Now, if you really want to get crazy with it, you can do something like this. Have I got this whole thing on camera? You can do something like this. Now, I'm holding this by the end, right? Now, it's very hard to hold, and it is very wibbly. It is very wobbly. Like, when you get this long, like, there's no helping that. It's just going to be wobbly. But I can hold this with one hand, with great difficulty, mind you, but I can hold this with one hand completely horizontally. It's bending, but it's not breaking, right? So that is the extent to which you can utilize this method to make long, sturdy objects. Now, if you want to see a little bit of a more practical build with this, I actually haven't picked this up since I re-glued it. You can use something like epoxy to help stabilize it, and you can do something like this. Here is a switch axe that I broke the axe off of. So, that is another option. That's using epoxy. It's not just super glue, so it's not as it's definitely helped by the fact that I'm using industrial strength epoxy to glue it together. But proof of concept there, right? So that's what we're going to do here. That's what I'm going to be teaching you. Let's go back to our screen here. So we're going to be splitting this blade up like that. Now, through that principle, we can also save on weight. We can make the main body of the sword as light as possible, while also making the pins themselves like. Another trade-off you have to think about is the more plastic you use, the stronger it gets, but also the heavier it gets, which, one, makes it hard to pick up and wield, and two, ironically, makes it weaker, because if you have something whose point, because if you have a sword whose point is heavy, it exerts more force on the handle or the base of the sword. So it can't take as much abuse because it's always got the edge, or it's always got the tip of the blade forcing. How do I explain this? If the tip of a blade is really heavy, then it exerts gravitational force on the base of it. So you always have that constant force wrenching on the base, so that if you add additional force like swinging it, it will break even sooner than if it was a light sword, if that makes sense. So, here's what I'm going to do. I'm going to do an offset plane. And the start is going to be an object. Oh, wait, I can't do it like that. Let's measure how far away the tip is. 56. So let's just do 300 meters, 300 millimeters away. And then we'll do another split. Oh, wait, what am I doing? I almost forgot something very important. When you're doing splitting, when you're splitting things up like this, what you want to do is you want to make sure that whatever component you're working on, you're keyed into that one. So if you want to go back and make edits on it, you can. Well, let me go into the blade. We're going to be editing the blade right now, so we want to make sure we're keyed into the blade. Because if we want to go back and make any edits to any singular part, we can go back into the blade's history and edit just that. We don't have to search through the entire timeline to figure out what we changed where when we changed the blade. I'll say that again. If we hit this little button on the component that we're working on, in this case the blade, it will queue up only the history of the blade, and we will be only working on the history of the blade. So if we want to retroactively go back and make changes to the blade after we've done a bunch of changes elsewhere, what we can do is we can click on this thing again and it will pull up just the blade's history. If you don't do that and you make any edits on the blade in the global history, and then you make a whole bunch of other edits, you're going to be searching in the timeline trying to figure out where the heck it was you made those edits on the blade. So it becomes just ridiculously cluttered. Anyway, let's do negative 300. So we're making a plane here, and what we can use, we're not going to do it right now. Well, I'll tell you about it later. So we're using create offset plane, and we're just going to drag this. Remember, we need to make 3 pieces here according to our plan. We did that, and then offset plane. And we wanted to do that right in the center of these two guys. Boom, something like that. Okay, so there we go. So now what we can do is, I think I just want to split up this main blade here first, the blade core. So we're going to use split body, click on this blade core and do that. Boom. Blade core 1, blade core. Why is it always numbers it so weird? Blade core 1 is here, blade core 2 is at the end, and blade core 3 is here. Go figure. Um, we're just gonna name this blade core 2 because remember 1 is right here. So blade core 1, blade core 4, and this is blade core 3. Indeed. Okay. So that's split up. That's cool. Oh, but I should probably say before we go creating pegs and slicing this up like that, what we should probably do is deal with these things first so we know exactly how far these things will be sticking into the blade, if that makes sense. But before we start slicing this up and making pegs run through the entire length of the blade core here, we first want to deal with this. This pattern here is going to be sticking into the blade. So what we want to do is make sure we do it first so we're not going to be interfering with any of the pins that we end up, any of the pins or pegs that we put in later. So let's have the blade go away, have the gilding go away, and have the blade core go away. So here's what I'm going to do. I'm going to hit E for extrude, and I'm going to click all of these bad boys here. Boom. Boom. And I'm just going to have that go down 1 millimeter. Like that. And then we'll E again. And we'll do the opposite side. One thing you could potentially do is like a mirror command to try to get that change you just did on this one, because I did mirror these two things originally, but like, I don't know, that seems like overkill. And that's also 1. Another thing we could do is we could go into, I'll show you, it's a little bit unwieldy. Wait a minute. We'll do edit. This is, oh, the feature was set to new body. We wanted to merge with that. Huh? What? What the heck? What did you merge with? Yeah, they're not what? They're not merging. Merge. Combine. Okay. Are you kidding me? It keeps switching over to it keeps Let's edit. Let's just delete that, I guess. Merge. 1 millimeter. Okay. Excuse me? Like they're separate bodies. Oh my god. Are you freaking kidding me? Okay. So let's do our interference thing. Are these two actually touching? Now you can use this yeah, I don't remember what it is. It says include adjacent faces. So if two faces are touching, obviously the two faces have zero volume themselves. So I'll tell you. But okay, yeah. So it says here 0 millimeters cubed, which means included. There's no volume that they're intersecting. It means that these two faces are exactly the same. So I don't know what the heck. Okay. Oh, I think I might know what's going on here. There's no bodies. We're working in the sword itself. We're working in the blade. Um, yeah, we're working on the blade component here, but all of these are in the sword pattern component. Gotcha. So it was trying to merge it with any and all bodies in the blade component, but there are no bodies like that in the blade component. They're all in the next component down. Okay. One, merge, boom. There we go. Yay. So to repeat that, I was in the blade component, this component here, doing edits there. But all of these guys, all of these bodies here, are one down in the sword pattern component. So when I was choosing merge, it was trying to merge it with any and all bodies in the blade component, which none of these are, so there were none. Oh my god. Guess I should be working from right to left then. So I'm not accidentally clicking on the god dang pop up there. There's probably a way to turn this thing off, this little pop-up box there. One, boom. So 1 millimeter. This is not like a structural thing, right? This is just an adornment on the side. So we don't need anything super duper fancy. Nothing super duper strong or whatever. No strong connections. We're just going to glue these in. Now that we've done that, we can go back up to the blade. And we can look at our blade core here. So our blade core, 1 and 2, span the entirety of this right here, of all of the pattern. So what we can go is we can go to our combine again, click this as our target body, and our tool body, we can go and click our sword pattern first body, hold shift, and select our every single one. And we hit OK. Remember, keep our tools. Boom. And now if we make the tool sword pattern go away, we can see it's carved this out nice and well there. Now we can do the same thing with the next one here. Select our target body as the blade core. Oh, shoot. And we probably should have done this before we split up the blade core, so we could just do this one time, but not too big of a deal. Okay. And then, like I said last time, if we turn off the sword pattern, we've got this nice, perfect split in there that we can glue it into. But here's the thing about 3D printing, right? We'll turn the cross guard off here. Here's the thing about 3D printing. Even if you make two things that are the exact same size for each other, the exact same fit, because of the limitations of 3D printing and it's not perfect, and sometimes there's a little bit of squeeze out to the side from the nozzle, you won't really be able to fit them in normally. You won't be able to You won't be able to just shove a 3 millimeter peg into a 3 millimeter hole perfectly. It's not really going to fit. So what we have to do is we have to give them a little bit of leeway, just a little bit, so that we can fit them in. And we're going to do this with the press pull command. Now, we could either adjust the sides of these guys. We could make the sides of these guys a little bit smaller, but that would actually mess with the... Actually, let me show you. Let's say I want to make this guy a little bit smaller so it fits in. Minus 0.05. Actually, no, not too bad. But I don't... The thing is, we'd be changing the size of this design here, which I don't really want to do. I feel like that might be a little bit more noticeable. I don't really want to mess with changing the design of this here. So what I'm going to do is I am going to change this. And I'll show you what I mean. You just click on every single one of these little walls. And this is very tedious. There might be some fancy like designer custom tool way that you could say, oh, select every wall that is adjacent to this face, right? Every face is adjacent to this face, but not this face. And this face or whatever. But every single one. And this is the absolute most fun part of work like this. Just selecting every single god dang part like this. And if you miss even one of them, when you print the thing out, you won't be able to insert what you want to insert properly. Spin it around. Almost forgot that one. Scary, scary. Boom. Okay, accidentally selected one thing that I didn't want to select. Wait, why is this not blue? Did we miss that one? Did we miss that one? Oh my god, we missed that wall. And yeah, we just go through and literally just select every single one. Another thing we can do is select every face here as well, just to create some leeway. And we go like this. And do the exact same god dang thing all over again. Now again, you could potentially do just the one and then try to use a mirror command to mirror it. And that could work, but it's a bit finicky sometimes, so I don't really want to deal with that, to be honest. Up, up, up. Almost forgot this guy. Of course, uh, looking through like the transparent side. Uh, it's hurting my brain. Hold up. Oops. At least the good news is if you miss one, you don't have to redo it. You can just edit the thing and then um select just the one more thing. Whatever you missed. Now that we've almost done with this, in my experience, negative 0.05 will do it. So you can see in total, you will have like 0.1 millimeter of leeway, right? Because it's 0.05 on both sides around the thing. So if you hold control, fun fact, it will show you what it looked like before, and then you let go of control and show you what it looks like after the thing. So you just kind of look at it, see if everything's pulsing properly. If it's good, you hit OK. And there we go. And if we turn the sword pattern back on, you can see there's a bit of a gap there. Kind of hard because of this dark color, but if we use our measure tool, it'll tell us, oh, yep, 0.05 millimeters. So now we can print this off separately, the little pieces, and then just glue them in. Okay, save as always. Dang, we're an hour in. But I shall proceed. That was probably the longest and most tedious part. So now I can move on to the blade core. So what we're going to do, we're going to make a sketch on the face of one of these bad guys. One of these bad boys. I'm having doubts. Did I mess this up? Um, no, not necessarily. So one thing that I didn't do that you can do if you have a really long thing is make sure that um one thing you can do is make sure that all of your pieces are the exact same size, the exact same length, so that way you can have the exact kind of pins for every single one of them, the exact length of pins. So if all of these were the exact same length, like if I measured this and split it up into equal parts, then I could theoretically make it so that all of the pins are the exact same length when I put them through, all the pegs that we will assemble them together. Like if you have a bunch of these things that are all the same length, then you just print out X number of them, and then it doesn't matter if you get them mixed up because they're all the same. So I got to figure out if I want to do that here. That's 230. $115. Okay, so I'm going to do this. These two will be connected by custom pins. These This junction will be connected by one form of pins. This junction and this junction will be connected by the exact same pin, the exact same kind of pin or peg. I'm using those terms interchangeably. Who's messaging me? Oh my god, check in to see my weekly report. I don't care. Don't buzz me when I need to turn that off. Anyway, so this thing, like I said, is 230 millimeters long. So we want to make a pin that is almost that length. Let's start from this side. And we'll make a sketch. Now I have a bit of a plan later. So let's just press P for project, get the size of this face. We're gonna press X for a construction line, and we're gonna get the exact half. This is the exact center in here, the center of this guy. And then we're gonna do another construction line, and we're gonna go down here. So what we're gonna do is we're gonna go into our polygon, and we're going to do inscribed polygon. Make sure it's not a construction line. And we're going to drag down here. And we're going to press tab and make sure it's got 4 sides. And this is going to be our peg. So we're going to click like that. Boom. Now you want there to be at least a millimeter of space here, I reckon. Because if it's too small, the problem is it'll be so close to the outside that it'll make the outside fragile. You want it to be thick enough that you can get all of the wall loops of this and all of the wall loops of that in between them. If you want to put 2 wall loops at 0.4 millimeters in there, then you would need this depth to be 0.4, 0.4, 0.4, 0.4, 1.6 millimeters. I'm going to do a little bit thicker than that. But that's what we're going to do here. And if we want it, let's see if we can change that. Using our construction line, draw like that. And then we're going to take our define parameters. Hold click here, and then you can freely select between two things that are coinciding. Click down like that. I'm just going to go, what was I going to say? 2.4. There. And that kind of pushes it down. And because it's stuck to the center, this should also be 2.4 millimeters. And there we go. So now we can have, 0.4 times 6, yeah, 24. So now we can have 3 wall loops on this guy, if we so choose, at 0.4 millimeters. All right, and now we're going to extrude. And we're going to say parallel, or equivalent, whatever. And we're going to do the span of the whole thing. But what we want to do is 230, which is the length of this guy, minus 1 millimeter. We still want there to be a backstop, so that when we put this in, we know when we've reached the end. But we don't want a lot of space in between pegs, because remember, this thing is the main structural peg here. This is the main thing that's going to be holding our this is going to be the main thing that's holding our blade together. So we want it to be as far throughout the entire thing as possible. So we want to do a new body. And okay, we hit okay. And then what we can do is we can do a move copy. Hit make a copy. And then we can figure out whatever this way is. Minus 230, which is the length of this thing. And if we do that, lo and behold, like if we turn off Blade Core 3, we'll hit OK. Oh, we measure this? We measure this? What's this? What's this? The length between here? 1 millimeter. Because we put in the length of Blade Core 3 minus 1. So that's where that 1 millimeter comes from. And then we can do something similar here. I'm going to turn off these guys so they're not getting in the way. Project out there. Get the midway of this rectangle like that. An inscribed polygon. We want a square. We can just kind of be like, okay, whatever. Change it. But actually, here's what we want to do. We want to project up this line here. Because remember, we're going to be dancing around that as well. We made the thing 2.4 millimeters, but 1 millimeter is chomped away from it, is bitten out of it. Because of the indent that we did before. So I don't really care about this being 2.4 millimeters too much. This is going to be like extra strong. I'm just going to do the 1.6 for this guy. There. 1.6. Actually, I'm thinking, what if what if and this is the beauty of doing things live. What if we just do this? We do another move copy of this guy. Move copy. Make the copy. Figure out what direction this is. Yeah. Easy. Easy peasy. And we hit OK. So now we've got 3 pegs of the same size, which makes it impossible for people to mix them all up. But that means it's sticking out the butt here. So before I can finish that, I want to take a little bit of a detour. And I want to extrude this guy. Whoa. Huh? What? What are you saying? Are you telling me these things are not coplanar? What? What? Zero degrees. Okay. 0 degrees. 0 degrees. So they're parallel. What? So why can I not extend you guys at the same time? Ah, this is so frustrating. I mirrored. This is made of 2 mirrored bodies. Um, but I guess the thing thinks it's slightly not um coplanar or something. Anyway, I just made this sketch there, which definitely is coplanar. Just for safety's sake, we'll do both sides and join. And we want to embed this. We want to embed this guy way deep in there. Right? We want this blade to just stick right in there. And this is why it's kind of handy that this thing was short. We can have this extend. We can stick way in there. How far can we get it? That should be good. Actually, if we do this, will it peek out? Oh my god, we can go all the way down there, can't we? And if we do this, then we can have the blade the handle here also join up into the blade. That'll be really good. for strength. Because our plan was to extend this loop in between up. Let's just do that. Boom. And we'll turn the crossguard off and the handle off just in case it wants to merge with that. And we'll hit OK. Because if we measure this, 224, yeah. We're within tolerances. Nice. That's actually perfect. So there we go. Let's go into the sketches and turn those off. Turn that off at least. And we'll go into the constructions and turn these guys off. Okay, so now we've got this thing here. It's choking because I'm using OBS. Am I dropping any frames with OBS? Nope. Cool. And we're just going to go through and we're going to combine everything. Combine this guy. Cut with this guy. Same thing. Keep tools. Okay. And then we're going to turn that guy back on, and we're going to turn this guy off. Because we're going to combine this guy, cut with these two. Okay, go. Keep the tools. And we're going to do that again. Combine. Cut this guy. Cut him with these two. And go. All right. And again, combine, cut with this guy. Boom. And so what that does is that makes a whole bunch of... Sorry, I just thought of something really handy that I could do. Anyway, lost my train of thought there. So what that does is that makes a bunch of these guys with holes in them. Like if we go down to our visualization settings and we go to the display style and we can go with shading and show hidden edges, it shows that inside, you can't see it from the outside, but inside that there are holes in there. And that's great. That's exactly what we want. Style, shading. Okay. Oh, wait, no. We want shading and edges. All right. For now, let's turn this guy into something a little bit brighter. Let's turn it purple. Oh, that's not bright. There we go. Let's turn it yellow so we can actually like see the shades, the actual shadows and stuff of what's going on. All right, so we've got this, right? And remember what I said before. We can't have just an exact fit. You will not be able to insert it all. Like you will be hammering down to try to get it in, and it will break the part before it will go all the way in. The friction is that great. So what we're going to do is we're going to click on these, press V to visually hide them, and we'll bring back our pegs. Now, we need to make this a little bit smaller so we can use our press pull here, but then we can just select everything. You can just select everything there. Awesome. And then do our minus 0.5. What's wrong? Oh, shoot, this is wrong. I selected the wrong tool, that's why. It's doing fillet. That's not what I want. Okay, choose offset. What kind of 3D printer do I roll with? I have A Bamboo Lab H2D. I'm blessed enough to have that. And an X1C because I'm a little bit of a nut. But yeah, welcome in. What kind of 3D printer you got? All right, minus 0.05 I found is a tolerance. There we go. And so now you can see it goes a little, ever so tinily away. But that should be good. So haven't got one yet? Nice, nice. Let me know if you need recommendations and stuff. I'm not a huge like 3D printer reviewer. I only have the two, and a couple not so great printers from prior in my 3D printing hobby. Yeah, it's certainly fun. If you type in exclamation point YouTube, you can check out my YouTube for stuff on that. Ooh, Elegoo? That's a resin one, right? That's a resin printer, not a FDM, a plastic one. If I remember that correctly. I've never worked with a resin printer. Seems kind of like a pain. But yeah, and then the next thing we're going to do is we're specifically going to back off all of these edges, these ends here, a little bit more. And because when we print the blade parts, what we're going to end up doing is not use supports. So we might get a little bit of a droopage in there. And we want to just make sure that these things aren't sticking out farther. That the droopage doesn't push them out. It'll be easier to show later. So I'll just do minus 0.3 for that. Okay. But yeah, I've never messed with a resin printer. I know they're a pain in the butt. If you don't have a designated space for them, like you need to make sure you get a space and have post processing and gloves and whatnot. That's why I like the plastic FDM ones. My face is blue. Hold on. Properties, video settings. I think because I like orange so much. Yay! Get some color in these cheeks. The white balance thinks, wow, that's a lot of orange. That's too much. We got to blue it down a bit. You have a room you can convert? Yeah, I recommend that. Make sure you got a window for like ventilation and stuff. The next thing we're gonna do, by the way, to show you what the heck I'm working on, I'm working on this Legend of Zelda Breath of the Wild Royal Guards or Royal Broadsword here. So here it is. I adapted a real, I adapted it from the actual game file, but of course I depolygonized it basically. I went through and I smoothed out all the polygons manually. But yeah, here's what it looks like in the sheath. Boom. I changed the color of the blade. Master Hunt, nice. I changed the color of the blade to yellow so it's easier to see because I was kind of working on a dark thing. But yeah. Okay, so where was I? Ah, yes. So now what we want to do is we want to round all of the corners of these guys. Just by a little bit, like half a millimeter. And the reason we want to do that, there's a couple reasons actually. One, oh wait, shoot. I selected a different component to work on. Anyway. Boom. 0.5. There's a couple reasons we want to do this, right? One is that due to how 3D printing works, sometimes corners aren't made perfectly. Like sometimes when you're printing a square hole, you don't get like an exact corner like this. You get something a little bit rounded. Just because of the way it works. So knocking off the corners helps to make sure that the pins will be able to fit into the hole regardless. The other thing is, I don't know if you can be able to hear this. Let me see if you can hear it. Oh. Did you hear that pop? That pop is a result of pressure differences. Because there is air rushing inside. Like, let me see if I can explain this. So when I pull this out, air wants to get inside, but it can't. It can't get around. It's kind of like a plunger, a little bit. Yeah. So the air can't. It's such a tight fit that the air can't really get in via the sides, right? And that's good. We want it to be a tight fit because we want it to have as much, support against the sides as possible. But what that means is if you it's like the plunger of a syringe, yes. They call that the plunger, right? Yeah. Anyway, I know what you mean. So because of that, if you make this a perfect fit, the air pressure will not, it will become airtight. And it won't let you push it in all the way. At the very least, it'll become a lot harder. So you want these rounded corners to allow you to actually put it on. And just to show you, Kragan, because you didn't see before, here was my concepts of making a strong multi-piece sword. One of the concepts. And here's another one. Yeah, that was just a proof of concept of like, how can I push this, right? So this is all 3D printed PLA and just super glue, like normal cyanoacrylate super glue. So yeah, but you can swing it around without breaking it. All right. So now what we can do here is, now that we've done all this, we can use our interference tool again to click here, shift click here, include coincident faces, and we can say go. Oh, and we did get some coincident faces. But the coincident faces are here, 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 and here, which is exactly what we expected. There are absolutely 0 coincident faces between the blade core itself and these 3 pegs. We'll call this peg 1, 2, peg 2, 3, and peg 3, 4. There. So that concludes these parts sticking together. So I'm going to put the appearance. Which one was it? No, that's black. There we go. Blade core. Yeah. Let's put this back in. Make late dinner. Have fun. It's 9:30 a.m. here in Japan. You'll be lurking? I appreciate it. Have fun making your diner. So yeah. Now we gotta split this bad boy up. Now there's a reason why I didn't just... Oh, this also needs to go back. Now there's a reason why I didn't just split the blade, the actual blade itself along the same axis, parts as the blade core. And that's because in order to make extra support, I actually want to cut it on either side of the cuts and use it to keep the blade core together. I'll show you exactly what I mean. So what I'm going to do is I'm going to turn the blade off here. Am I getting a message? Is it an important message, or is it like freaking Google Photos saying, oh, somebody blah, 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 blah? Someone reply to my comment. I had an argument over Chica. We don't need to talk about it. Anyway. So what I'm going to do here is I'm going to create a... What the heck? I hate... I'm going to create a sketch off to the side of here. Create a offset plane. Doesn't need to be necessarily on the body itself. We'll create a sketch, and we'll do it right here. Okay, never mind. I need to frickin' turn this thing back to white or whatever. It's too dark for my taste. Sure. Let's go back and edit this. What we're going to do is we're just going to project all of this all down the side of the blade core. We're going to hit OK. All right. So now that we've got this thing projected here, we're going to draw a straight line from the top center all the way down to the bottom. And what we're going to do is we're going to take off our construction lines. We're going to do an offset of this entire line on both sides. And we're just going to make it, it doesn't need to be anything big. It's just going to be 0.5. 0.5 millimeters. And we're going to do it again, minus 0.5 millimeters. And then we're going to cap it off up top. So you see right here, bada bing, bada boom, we've got this rectangle. Now we're going to make a polygon at every... We're going to make a polygon at every single line where it's cut. So this is a cut between two. This is a cut between two. And this is a cut between the two. We're going to make a little diamond. Where'd it go? Polygon, inscribed polygon. This guy, right? Tab 4. Tab 4. Why not? Boom. Let's clear this. That's where the colors change. We're going to do the exact same thing. 4 millimeters. Boom. Whoa. Messed up. Click the wrong place. Try that again. And at this junction, 4 millimeters, 4 sides. Okay. So here's the idea. I don't know why, if you click on like the left side, it doesn't let you rotate freely. Anyway. We're going to finish that sketch. Ooh. Never mind. We're going to edit it again. And we're going to cap it off here. So it doesn't reach all the way to the top. All right, okay. So if we hit extrude, E for extrude, select this, And you can select the start is an object. Oh, this is where it gets frustrating. We're probably going to have to do this once for every single face here, which sucks. Um, yeah, okay. I'll show you exactly what I'm trying to do here in a bit. But we're going to have to separate this thing off. Which is a pain. We really should be able to do this all at once, but, you know, whatever. So what we can do is we can hit E for extrude, select this, the corresponding uh, profile, and then when we go to start, we can choose object, and we can select this face as the start. And then we can make it, oh, I don't know. Huh? The heck? Oh, the blade's still on. We can put it out 5 millimeters like this. Yeah. And then we can do that over and over and over. Start as the object, this guy. What the heck? I hate it when it does this. We chose merge, and it frickin' merged these two guys. It merged these two bodies together. We don't want to do that. So we'll turn that guy off. We'll turn Blade Core 3 off so it doesn't get caught in the merge. But we can extrude again, select this, this, and then the start will be this object. -5. Okay. So here's where the magic happens. We can select this profile and then select the object start is this. And we go -5. It will smoothly transition it up like that, which is super handy. So we can do that again. -5, except, oh, no, we want like that. Again, -5, profile start. Yeah. Make this guy invisible for now. Again, -5, except we want you to start here. And we just keep going through like this. -5. Profile start this object. And I really wish I could have done this all at once, but, and just selected all the bodies, but Fusion, I guess, would throw a tantrum if I tried to do that. That'd be too easy. My 5. Object. My 5. There. So now we've got this entire blade core. And the purpose of this is, when we print the blade core, it won't need any supports because it'll always be supported by this little ridge. But we can use this little ridge as well to keep the blade itself attached, and the blade itself will keep these two things clamped together. We'll keep this blade core 1 and blade core 2 will be clamped together if we cut the blade itself down like this. We can turn this sketch off. Yeah. I'm thinking. What orientation do I want to print? The question I have for myself is, what orientation do I want to print the blade in? I kind of want to print it flat. I don't know if it'll matter though. If I print it flat, then the layer lines. See, if I print it flat, like this. If I printed it like straight up like this, then it will be more structurally sound when in holding these parts together. But if I print it straight up like this, it'll be less structurally sound, but it will look a little bit nicer in terms of quality, I think. Maybe. Especially down here at the actual blade. I'll print it right side up. I don't think it matters too much. So, we gotta cut it up again. But the difference this time being, we don't care about necessarily making it normal sizes, normalized sizes. Well, whatever. We don't really care about making it like the exact same size so we can replicate pins in it or whatever. But we do care about just making sure that we split these guys here. So we'll just go up until there. Yep. Okay. Oh, but these guys are so skinny. Okay, I'm having we'll print them lying flat. How much distance from here to here? What? No, how much distance from thi this face to this? 178? That's acceptable. Okay. But I can't print some of these guys flat because they're all like curvy. Hmm. Decisions, decisions. Because like if we look at, let's measure this, right? This thing is the thickness, 13 millimeters. So we're looking at something that's like, let me show you that. Actually, no, I don't have. I do have my caliper on me right here. So 13 millimeters. It's about that. That's skinny. And imagine that 20 millimeter. 100. This is 150 millimeters. It's like printing that straight up is kind of dangerous, I think. So you might just have to cut it into smaller pieces. That might be for the best. Here and here. Okay, no. Here and here. 200, yeah. Oh, well, in any case, before I do that, let's do a little mirror thing. We'll construct a plane through. Construct a plane at midpoint. We'll select this face, and we'll select that. What the? No. Oh my God. Select the face I want. I want. Is this not a face? Is that not a flat face? What? 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 That is though. Okay, whatever. Okay. I guess technically that's not a flat face. Whatever. And we can use the mirror command, mira, and we can select features and all these god dang things And we can choose this guy as our mirror. And look at that. You can see it shows up right on the exact opposite side. Okay. And then it just doesn't show up. Awesome. I hate it when Fusion does this. Like I literally like you're literally showing me the exact thing that I want. Yes, do that. Okay. Yay, no errors or anything. But it didn't happen. Ah! I'm having an aneurysm. But it did. But this. So I guess again, we need to do the exact same thing we did last time, which is like technically faster. Oh my god. Oh my god. It's like, yeah, you did that, mirror. No, you didn't. You're an idiot. Ah. That's what I was saying before. I didn't want to use the mirror command because it just gets so stupid sometimes. Anyway, so now we got to do extrusion for every single one of these goddamn things, I guess. Oh my god. Okay. All over again. Five. Boom. Okay. Again. Five. Okay. Five. Five. Okay. E. Do that. Object. Five. Okay. I thought this was a computer. Shouldn't I be able to automate this crud? Oh. Object. The start is going to be this object. We got to be careful that we don't merge it with Blade Core 1 like we did last time, that one time. All right. Blade Core 1. Oh, I chose offset. I accidentally changed the offset. There we go. Merge that. Nope, I changed the offset again. 0, 5. Oh, this is the object I want to select. There. Jesus Christ. Now that we've done that nightmare, another thing we can do for strength, because this is kind of thin, like a 5 millimeter tall, 1 millimeter thick thing, probably want to add a little bit of a fillet to it. Hopefully it doesn't throw an error. So what this is doing is it's providing a gradual curve to ease into this protrusion here, so that all of the force, if everybody gets knocked sideways, doesn't apply directly. Like, if something is standing on something else like this, it's really easy to snap off, right? But if it's like this, and it's kind of stuck on there, it's a little bit harder. Yay. So there we go. Nice. Hmm. So we still have the problem of how do I actually want to cut this up? What do we think is an acceptable height for something that's like 13 millimeters thick? What's an acceptable height to print? Maybe 100 centimeters? I don't think that's too ridiculous. Let's go with that. But first, let's cut this guy up. Before we cut it all into a bunch of different pieces, let's do all the modifications at once. Cut pieces right out of this guy. Okay. Keep the tools. Boom. We can remove the blade core and the pegs. So yeah, nice. We've got this lovely little thing. And the other side effect of it, of this fillet is it now makes this like really nice entry, really easy entry to stick it into. But we gotta widen this bad boy. Same idea as last time. Just selected all these god dang things. I wonder if there's a way to do the interference command. Select all the faces that, are touching and then um like use that as a selection set for this. Like, oh, find all the faces between these two things that are touching. Okay, now that you've found all the faces, offset them. Oh, nice. We love it when it's all one big selection. This is probably the most tedious part. Like, the blade is going to be the most tedious part of going through and doing all this. So I think it'll be smooth sailing after this. And then we gotta select the fillets. And again, we'll do the typical 0.05 once we get all these bad boys selected. Negative 0.05. Oh God, please. No! I select all those god dang things and it throws an error. Jesus freaking Christ. Of course, it doesn't tell you um which things caused you an error, you know. It just says, "Oh, something's wrong." Jesus Christ. Of course, there's no reason it should be if I did everything correctly. Maybe I didn't do everything correctly, but I don't know. It doesn't tell you. All right, let's try it on the other side then. Ugh. Of course, there's no saving that and going in and editing it. You cannot save, as far as I know, you are not allowed to save a feature that has like 0 entered into it. Like you can't save an offset that has 0 inputted into it. So it's like if you have something that's an error, you can't just hold on to it and then mess with it later. Oh my God. I actually chose a point, so it thinks, oh, you want me to offset it to this point? No, I don't. I very much do not. Oh my goodness gracious. Negative 0.05. Okay, so I can just do that. Cool. I'm not sure why it can't do that to the, functionally the same thing. I'm just going to say 0 in there. Until we do this. Who knows? Maybe there was one like face that I accidentally selected on the other thing that was messed up, and if I had deselected it or, I didn't select one face that helped everything. But the thing is, the error messages on Fusion don't tell you diddly squat. Theoretically, it should be able to tell you, hey, this is what's messed up. Like if we did it with just these things, it would be all hunky dory. But this one's funky. Woo woo woo. And then that. And then finally, that. Minus 0.05. Oh, God. So now, if we bring the blade back, we can go, hey, guys, is there any interference between these guys? It says, yes, there is. It's touching here, here, and here, which is exactly what we expected. I gotta go to the bathroom. I'll be right back. Okay, I'm back. All right, so now that that is confirmed to be A-okay, we don't need this, do we? Why is my scrolling all messed up? Like, there we go. I don't think we necessarily need these two guys now, do we? It's okay. We don't need this now, do we? We do not, no. So it's saying, oh, this feature is referenced from by other things in the timeline. Are you sure you want to delete it? The reason why it's saying, um, this guy, like this fillet, was editing that extrusion, but now it's not. So if we go in and we say, hey, you're good, Don't worry about it. It'll be like, oh, okay. All right, so I'm not gonna lie. Part of me just wants to include the gilding on the blade core because I have an H2D, and then just tell people, hey, if you want to like cut it off, knock yourself out, but I don't care. you know. Yeah, I think I'll just do that. There we go. Oh, it's doing this crap again. There's like a weird glitch I've run into before where it doesn't split things always. It's like buggy. Let's just go back and do a separate thing. There. What the frick? I think I went a little bit too far back. It was this split body, wasn't it? Yep. Okay, so this is the split body. Yeah. So now we're just going to do a similar thing. To the gilding. We'll split that, and we'll split that. Why? Well, I'm sorry. We can't find the geometry. What are you talking about? you know? Ah! Split this guy 3 times. Okay? Boom. Not complicated. Oh my god. Too ridiculous. Why do I want to give them access to public whatever? All right, send the error report. This is why you save a lot, folks. Okay. That's disheartening. Good thing I saved often, though. See how much progress I lost. Did make a recovery document. Anyway. Did it? Oh my God. Did it not save the? I don't think it saved the offset face that we did. Oh. Yeah, no, it didn't. It did not. Okay. Let me just double check. God dang it. That is discouraging. But it did delete. Let's look at the non-recovered version. But it did delete these. I thought I deleted these things after doing the offset. Oh my God. Okay, well, Guess I'll redo that then. Press pull. If you ever have a problem like that where it won't let you select multiple items that you want to select for press pull, make sure you're not in automatic and that you're on new offset. That should fix it for you. Okay, do all this again. Thought I saved after this, but you know, usually tend to save after really tedious operations like this. But you know, whatever. Can't believe it. What did it crash on? Oh, split this body. Exactly the way that I split this other body. Nope, can't do that. Boom, dead. That's dangerous. Don't want to select the entire. Well, what am I doing? Top part of the sword. My .05. Okay. Save. I'm so frustrated. Okay, let's do another interference analysis. Go. All right, nice. That is what we want. Although, come to think of it, we should probably, just to be safe, add that. And add that real quick. So that there are genuinely no interferences or no coincident faces with these two bodies. Like, we want every single one. Blade Core 1, Blade Core 2 touching. Wait, I don't think we did all of them. Blade Core 1, 2, 3, 4, Blade. Go. Yep. It should say Blade 1, Blade. If there's any problems, but there aren't. Oh, okay. I wonder. Turn the blade off. Oh, nice. What do you mean? 4.999. Can't go all the way up to 5, but you can go to 4.999. Now this is specifically just to really. So we can do that, but on this theoretically opposite 0.99. Okay, well that one's sensitive. It can only go to 9. 4.9. 4.94. Okay. Any more of that than that and it riots. Oh, actually I wonder, can I if I were to measure here to here 4.95. Okay. I don't know why it's not 5. It's supposed to be 5, but whatever. And I assume this is like 4.99 or something. It is just 5. Okay. I don't know. Whatever. It doesn't matter. Shouldn't matter. Okay. Now to try to do the thing that I wanted it to do before it completely crashed. Split this body and that body like that. Okay? Can you do that for me? Thank you. Split this body and that body with that. Can you do that for me? Thank you. Split this body and that body with that. Can you do that for me? Wow! Each of the 3 operations I wanted to do in the same one fell swoop were done in a matter of seconds. Anyway. Top gilding right 1. Top gilding right 2. Oh my god, this is definitely left. Bottom gilding right 1. Bottom gilding left 2. Top gilding, left 2. Top gilding, right 3. Right 2. Left 3. Just naming all these so I can keep track of them. Top gilding, left 3. Four. Right 3. Bottom gilding 4. And this guy, right 1. Left 1. Okay. Sweet. Awesome. Now later, not right now. I don't want to mess with that right now, but later I'll have to move them into their own components. So they all have their name. Ugh. Their names all work out. Okay. Now all we need to do is cut up the blade. The blade's blade. Minus 100. Minus 200. Excuse me? Oh no. No, I messed up. Like, I don't think there's any way to force stop an operation in Fusion. Like, if you mess up and you click the wrong thing, there's no way to say, hey, don't do that. Please. Okay. I actually did offset face, not offset plane. Hmm. Yeah, it's fine. minus 400 minus 500 minus 600 minus 700 minus 800 minus 900. That last one probably isn't necessary. Oh, last two aren't necessary. Boop, boop. So now, save, because apparently it doesn't like splitting bodies like that. Boop, 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 boop. Go. We're gonna name them A, B, and C, I think. A, B, C, D. A, B, C, D, E, F, G, H. So your blade H. And your blade C right. Oh, goody. We've already got the stupids. Like, why didn't... Why did you not get split, right? Okay, go. And why did you not get split? Go. C left. Blade cleft. E left. Why did you not get split? Blade E right. G right. Blade right. Blade left. Blade right. Blade a left. Blade left. Right. Blight. Left. Right. No, it's blade right. God dang it. All right. Oh my God. So that should be the blade done. At least, it might have some minor alterations because of like, oh good, other things interacting with it. But that should be it. Oh, maybe no, I wanna fix this. Oh my God. It's gonna stick into blade alright. Yeah, so I'm just making these so they won't need supports. I might have to edit this later. This is kind of a stopgap solution, but if it's the last thing we're doing, I'm not too worried about it. So the last thing we want to do is we want to separate it into components based off of what parts we want to print together. Oh, how do I want to do this? So one hard thing that's going to be is, like, for example, I've got the sword pattern all in its own um, separate thing, but the truth will be I want to like take this and the guys on the other side and stick it with. Actually, no, it's fine on its own. No. What am I talking about? It's gonna be fine on its own because we want to print it out separately, right? We want to print it out all its own separate thing. We want it all to be together. So what putting all these things together means is that um, we can print it all on the same build plate, which, just out of curiosity, how long is that? 250? Okay. We put it on diagonally, it should be fine. Um, yeah, so you want to print these guys all on the same build plate, basically. Keep them separate. Okay. Okie do. But for example, we want to put this blade we want to put this blade core 1 with all of the blade A pieces. We want to put those all together because we're going to be printing them together. Anyway, I'll show you what I mean. So what we're going to do is for blade core 1, we're going to um, make a component from the body. And it's going to be blade core 1. And then we're going to find all of the A ones, the gildings. A, all 4 A, blade A left. No. No. We're going to find the gilding ones. 1, 1, 1. Why were they already underlined? Anyway, and we're going to right click. We're going to move to group. We're going to select which group. It's going to be the blade core 1 and this folder here. And we're going to say okay. Boom. So now blade core 1 has all those bodies in it. So if we turn it off, all of those bodies disappear with it because we want to print them together. I just realized I don't need this and I don't need that because I can just print it on the top. Delete. Delete. No. Delete. 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 You're kidding me, right? Why does this matter? Why? What? How did deleting a feature on the blade core down here cause these 4 to fail? Did it cause deleting those caused this split body to magically be successful? No? No, it didn't. It caused it to fail more. Why? Why? Age right, right? H G A B C D E. Oh, okay. So everything's messed up and oh god. Everything got changed around for some stupid reason. So yeah, like Fusion's super bugging out. I don't know what it is with the split body command, but like it just doesn't know how to operate sometimes. And so me changing like some completely unrelated feature absolutely busted it. Yeah, I know. Okay, are there any more weird blade shenanigans that need to be fixed? Okay, no. Just need to rename everything. A, B, C, D. Like, why did it change everything's name? That's Blade H. That's fine. No, that's Blade Left. What the heck? That's Crew. G right. A right. C right. D right. E right. Where is Blade E right? Why can't I not name it Blade E right? Oh my god. A, B, C, D. Blade D left. That is actually C left. And that's D left. That's A right. Huh? Why did you rename this one? This is actually E left. That is C left. That's D left. What the heck? That's A left. Why did you change this one too? You are D left. Oh my god. We're going to restart. Oh god. I'm getting irritated. Might have to break for lunch soon. So yell at me, you can only open one instance of Fusion at a time. I know. I closed the last one. Uh, you are A left. A left and A right. B left. Okay? That's B right. Okay, that's correct. C left. Good. C right. Good. D left. Good. D right. Good. E left. Good. E right. But you don't need the 1. Thank you. Okay, so it's just totally glitched out. F left. F right. G left. G right. And then H. And save. Holy cow. All right. Okay. So now that we've got that absolute crap shenanigans taken away. Let's go back to what we were doing before. Oh, sweet. The Blade Core 1 that I did before didn't save. All right. Make a component out of it. And then we take all of the gildings. And then we move into the group. Oh my god. It's glitched out. I can't move them to the group. Oh wait. No. Oh my god. I'm just dumb. I went back in the timeline. Like, no, you can't move that in the group because you've already moved the group in the future. For once, I was making a mistake instead of fusion. All right. Good. All right. Blade 2, make a component. Blade Core 2, and all the gildings. Left, gilding right. 2. Okay. Boom. And then we make Blade Core 3. Move to group. Pick the group. Blade Core 3. Boom. Blade Core 4. And then these guys. Just the 2 of them. Move to group. And the group we moved them to is here. Okay, nice. So, if we go through here, there, that disappears. That completely disappears. That completely disappears. That completely disappears. Whoo! I think we got to take a lunch break there, folks. I'm going to end stream, eat, and then come back to finish this thing off. Bye.